So last time we talked about how to find the principal stresses, and then the fact that in a homogeneous half space, one of the principal stresses is always vertical, right? So the other two are horizontal. And we can idealize the Earth as that in that scenario. So we always have one principal stress vertical pointed into the Earth, and the other two in some plane defined as where the vertical stress is normal to that plane. In that plane, the two horizontal stresses are SH min and SH max. So there's a common fault classification scheme, Anderson or Andersonian fault classification scheme, that's based on these assumptions that the vertical stress is always principal stress and then the other two stresses. And so then you can characterize the types of faults we talked about previously in relation to these principal stresses. And that's the Anderson fault classification scheme. So the first one we talked about is the normal fault. And you remember, how do we characterize? I kind of gave you a hint as to how to characterize the normal fault. And it's normal to what? The motion of the hanging wall is normal to what? Gravity, right? So in this case, the vertical stress is greater than the two horizontal stresses to accommodate that motion, right? So if the vertical stress, which remember stress multiplied by an area and you have force, so you can think of the vertical force is such to accommodate hanging wall motion in the same direction as gravity, right? And then the other two are characterized by which stress intersects in a plane normal to the fault. So in this case, well, not normal, but let's say oblique. And so here's our plane fault, our fault plane, and then this stress intersects that plane obliquely, right? And in this case, in the normal faulting regime, that would be SH min. And I'm trying to use the same notation as what's in the book, Zobac's book. So there's also been some questions about, where we are in the book. Well, we're still in chapter 1, and we'll cross over briefly into chapter 2 today. But for the most part, we'll just finish up chapter 1 today. And so I'm trying to follow the consistent notation with that. So then we have the reverse fault, which is just the opposite, right? So again, in this case, the vertical stress is less than the two horizontal stresses to accommodate the motion of the hanging wall moving up, right? And again, just like I said before, the kind of hint to remember the reverse fault is that the hanging wall moves in the reverse of gravity. And then the other characteristic of this is that now, if we have our fault plane, it's SH max that crosses that plane obliquely. And so then the third case is the strike slip fault, and in this case the vertical stress is in between the maximum and minimum horizontal stresses, and I had to put these blue vectors on here, and it was a little bit difficult to do it in such a way, but the point here is that this vector, it's not actually pointing up, it's in the same plane as the, it's in the horizontal plane. So I tried to show that. But it's the horizontal SH min, SH max are not necessarily in the direction of, along parallel to the fault line. So they cross it at some angle in a strike slip scenario. So just in summary, we have this chart. I think there was a similar chart in the book, and possibly it would have been more easier to remember if I would have placed strike slip between normal and reverse, because then you just have the vertical stress along the diagonal, right? So where S1, S2, and S3, remember, are the principal stresses, and they're always defined where S1 is greater than S2 is greater than S3. So this is the Anderson or Andersonian fault classification scheme. What's that?
On that strike slip, there's two. Let's say SH max.
Ah, thank you. I'll fix that. This is SH min. Just also following the notation of Zoback, you'll notice that the H is capital in the max and small in the min. So I intended to do the right thing there. I'll fix that in the slides in case you guys check these later.